Hello and welcome to the Superposition Guys podcast. My name is Yuval, and my guest today is Denis Mandich, CTO of Qrypt, a post-quantum encryption systems company. Denis and I talk about their unique approach to security that replaces key distribution with key generation at the endpoint implemented via software, how their solution works for air-gapped devices, their price structure, the human right to privacy, and much more. We hope you enjoyed this episode. Hello, Denis. Thank you for joining me today.
Nice to meet you, Yuval.
So who are you and what do you do?
I'm the CTO and co-founder of Qrypt. We're a post-quantum encryption systems company building solutions that will be secure against quantum computers.
To an outsider, all quantum security companies might look the same, right? Everyone's talking about key distribution or post-quantum cryptography. So help me make some sense. How would you distinguish yourself from others? And to the extent you can, could you sort of map out the market for us?
Sure. I think where we are today is the natural progression from using the same sort of solutions that we did in the 1970s, which was a single piece of copper wire and a handful of switches connected to people. It's where public key infrastructure came from. And the basis for that is key distribution. And for the quantum era, the world we live in today, which is the cloud, virtualized environments, containerized systems, we really need to move on from that model where it's a single point of failure based on a single algorithm. Many of these were developed in the last few decades and are the ones that are subject to attack by quantum computers. So what Qrypt does is really do away with the distribution piece and replace that with key generation at the endpoints. Very similar to what you find in quantum key distribution, but we do it exclusively through software on existing commercial infrastructure.
So I'm an enterprise customer. I go to your website and I read the heading, safeguard your enterprise data with quantum secure encryption. I said, this sounds great. How does it work in practice? How does implementation happen?
In practice, if you do away with the original sin of using PKI to establish key agreement and isolate that to a separate channel that's decoupled from the actual data channel in which you're encrypting the data, you're already halfway there. And if you can do away with the mechanism of distributing the keys altogether, you've gone all the way. So the way to do that is instead of using the current algorithms, RSA, and elliptical curves, or the post-quantum ones like Kyber to distribute keys, you can use them to exchange a small amount of metadata, which allows them to access Qrypt's quantum resources in the cloud. These are hardware sources. They're quantum entropy sources co-developed with Los Alamos and Oak Ridge National Labs and big universities around the world. Those clouds allow you to download several strings of random from multiple different geographically isolated locations. And then the software, the SDKs at the endpoint assembles those into a single pool, and the cryptographic extractors turn those into symmetric encryption keys. And those can now be used in the same channel that was used for that first piece of public key exchange to distribute the encrypted data, but that data was made or encrypted with keys that were from a completely different mechanism unrelated to that channel. So that does away with a single point of failure that is really behind the biggest headlines today, which is harvest now and decrypt later. If I put all my eggs into that one channel and I rely on the security and the perfect implementation of those algorithms and the software behind them in that channel, then that's a single point of failure. And we just saw a huge example of that just in the last 2 weeks. We've seen two major ones, global ones.
So if you got two endpoints and they're exchanging some metadata and then they're downloading essentially keys or key fragments from a server, doesn't that become the point of failure?
So you're downloading quantum random that's generated from quantum entropy sources at multiple different locations in the cloud. And there's no single source that you're getting it from. And everyone in the world can use any one of these sources, but you'll get different combinations of them. So downloading those to the endpoints isn't enough information for you even to restore the key material that's ultimately used. It's only enough information to assemble the raw materials and then apply the cryptographic extractors, destroying a lot of that information from a separate channel. So you eliminated effectively the single point of attack. Yes, if someone is actually monitoring everything that goes in and out of your cell phone or your endpoint device, you can only achieve computational security. But it's, of course, far more complex to do it the way we're doing it, and it's a much harder problem. But in this case, if you missed any one of those API calls to the cloud or any piece of those random strings from the cloud, then you get nothing.
So your solution, so there's the cloud piece, of course, and then there's software that sits on the endpoint. So it is a software-only solution for the endpoints?
That's right. You only need the software to effectively achieve the same levels of security that you get with quantum key distribution. We've inverted the model on its head and put those quantum entropy sources in the cloud instead of two physics appliances at the endpoints, which will never fit inside of a mobile device or a laptop or anything like that.
What is the stage of the company or the technology? Is this already deployed? Can you tell me where, for instance?
Yeah, it's already deployed and you can download it for free, a trial version from our website, and use it to make your own applications. So if you're trying to build something like a messaging application and you want security guarantees that go beyond the ones that you get from WhatsApp or Signal or anyone else, they're not involved in the key generation mechanism at the endpoint now. They only become the transport mechanism for the actual encrypted content, the payload. So we did a demonstration of this application with an open source messaging and file transfer service. It's called Mattermost. A lot of the financial industry uses this, the government, military, like the Air Force. And it's a simple test case that you can deploy today on your own, even without our help. Of course, we're here to help and provide services to make that easier for you, but it's an easy way to get started.
Is there any sense of making this for an air-gapped version? I mean, it sounds like I have to download something from the cloud. So what if I can't download at the moment? I'm running this on a cell phone, I'm out of coverage, or I just don't want to connect to the cloud. How would that work?
You can do exactly everything that I just described and download that to a single endpoint or multiple different endpoints and take all that key material and put it onto your air-gapped network. This is in fact what Qrypt does for our engineering network. So we practice what we preach. During COVID, we were forced to remove everyone from our laboratories and our dev teams, which are on a separate system inside the company, and deploy them all around the world. Some people wanted to move out to California and other places. So we had to get that key material to them in exactly the same way we're doing here with companies like Mattermost. And now you take that key material, use it completely on your air-gapped network, where you consume the key material and destroy it as it's consumed. And now you can upload all those files to the regular internet without any fear of them being harvested and decrypted later. And we operate in two modes. One is for AES 256, which is considered quantum safe. And then we go up to the full government top secret classified code word one-time pad-based system, where now you can post it on Facebook and it can never be decrypted. So that's the difference between encryption that's computationally secure and information theoretically secure.
Would your big goal be that every computer, every operating system would essentially have this security component, or is it targeted at specific applications or specific geographies? Maybe you only want it in the US or something else. Maybe you could tell me about that a little bit.
Yeah, we're initially targeting, of course, the financial industry, the healthcare industry, government, and telecoms, because they're in compliance. They must transition to post-quantum cryptography, but they also must have higher security guarantees than the people exchanging cat videos. But our vision is to deploy this everywhere in the world and transform the cryptographic architecture of the internet itself, which was really designed and built around monetizing and data mining. We think that should go away, and we should restore privacy the same way we had it before the internet existed. And this is a way to do it. We do not have all the information that you downloaded from us to be able to replicate the keys, because that little bit of PKI metadata they exchange contains the recipe or the cryptographic extractor parameters that will ultimately be used to make the key. And we never had access to that. We just made all the raw materials available so that there can never be a man in the middle. Nothing happens outside of the endpoints. The keys are never in flight. You saw this was a spectacular fail for Zoom during COVID, when it was discovered that their end-to-end encryption was actually end-to-end, but not from the client endpoints, end-to-end to their server in China. and then from that Chinese server back to another endpoint in the US.
Is there any standards effort that would govern or that you could say, well, we're compliant to X, or is it just something that you say, well, this really makes sense, we're just going to deploy it out there?
We're using the same compliance-based algorithms, and we absolutely believe no one should roll their own crypto. There's no security through obscurity here. We have published everything. So we use those same post-quantum algorithms like Kyber to do that metadata exchange that establishes that key at the endpoint. We just use it in a different way. Instead of distributing keys, that's the mechanism that needs to go away forever and be replaced with a mechanism like what Qrypt is doing. It doesn't have to be what Qrypt is doing, but this is a perfect solution in this market ready right now to overcome that burden of the harvest now and decrypt later threat.
And if I'm a customer, do I get charged by the number of keys I download, or is it per endpoint? How does it work financially?
Since it doesn't really matter how many endpoints you have, it really matters how much entropy you consume from the cloud. So if you're only generating AES keys, which we do this right now for some customers that use HashiCorp Vault. So they go through all the trouble of deploying a HashiCorp Vault, but they still need to get the keys in and out of that repository in a secure way that's durable over time. So that's an example of where you can immediately deploy Qrypt as a solution to get as many keys as you want. However, that is only considered quantum safe, not quantum secure. If you would like to go up to a fully quantum secure one-time pad-based system, then you need as much random entropy from the cloud as data you have. So if you're transmitting gigabytes of data, it's no longer the 256 bits of an AES key. It's more than the gigabits of data that you need to encrypt.
Given that you're taking care of the keys, sounds like you don't have a horse in the race of what standard NIST comes up with or recommends, or you're essentially agnostic to whatever standard the customer wants to use.
We will comply with it because we're dealing in compliance industries. The financial industry doesn't have an option. The government, by directives, by legislation, by national security memoranda, must adopt these new algorithms within the next decade, have them fully deployed for every government agencies. There's no waiver. There's no exceptions to that. It's going to take a long time. We're suggesting, since we're going through this massive transition, we've never done anything like this before cryptographically. Last time was 2 decades ago when the internet was a fraction of its size today. We're in uncharted territory. This is probably going to take a lot longer. And if we're going to do that, we must graduate away from these archaic technologies, these centralized single points of failure, and move on to something more modern like what Qrypt is doing.
Tell me a little bit of the backstory. How did the company started? What's your background?
So the co-founder and I were both from the intelligence community. We saw the scale of theft by the Chinese and the monetization of IP that was stolen. This is going over 10 or 15 years. And really a decade ago, at the time, the head of the NSA, General Alexander, came out and publicly said, look, this is the single greatest transfer of wealth from one country to another in human history. We don't know if we survived this or where this goes. We saw so much of it being done very poorly. The Chinese adopting a Cold War era mindset of like, look, let's get all the data that we can get. We don't know if we can decrypt it. We don't know if there will be a flaw found in it, but we see this time and time again being very successful. And they started collecting data on a scale we had never seen before, playing the 100-year game instead of us, the 2 to 4 year election cycle game. And they were very successful doing that. And that was more than a decade ago. So Kevin Chalker and I, the co-founder, really wanted to do something about it, make something more durable, something akin to the ones that we used inside the intelligence community, which were already considered quantum secure and quantum safe. And we never worried about our communications. We were very confident it was strong. And we wanted to see that in every enterprise and at the user level. That people needed their privacy back. They need to have those communications without, the big social media companies data mining it and selling us ads, without Big Brother or whatever it may be.
Professionally speaking, what keeps you up at night?
The possibility that my kids will work for Huawei one day because we have given away so much IP and allowed so much penetration of our networks that it's not coverable anymore.
And hypothetical, If you could have dinner with one of the quantum or one of the security greats, dead or alive, who would that person be?
Oh my, one of the security greats. It'll be Claude Shannon and John von Neumann.
So Claude Shannon, I guess, is the Richard Feynman version of the security folks, but in terms of the most common answer. But who else?
Yeah, it's really some of the ideas and the proofs really came out of physics. So he was inspired to call a lot of the foundation of information theory by one of the most famous little-known physicists, John von Neumann, who came up with the quantum theory of entropy and how that could be used for secure communications. So the other big ones would probably be, I'm trying to think, from the 1980s and 90s when people really started putting together great solutions that were durable. It's so many people that were involved. It was a collective effort. I can't say it was just one person who inspired me. It was really just our desire to do something better and stronger and faster and easier to deploy that really drove us, and really realize, the vision of Claude Shannon. It's like, look, we can get to something that's the end goal of all of cryptography, something that's information theoretically secure today. We can do this now. Why aren't we doing this? Why are we tolerating all this data mining, monetization of it?
Denis, thank you so much for joining me today.
You're welcome. It's great talking to you.